Hello once again, everyone. My name is Ben Weekly, and welcome back to low pressure boiler training. This is going to be the fifth session in a series of training videos that I've recorded and put onto YouTube. This session will deal with fuel systems in boilers, low pressure. Before I get into all of that stuff, I once again want to talk to you about the boiler books that complement my video series. And I highly recommend that you buy these boiler books and follow along chapter by chapter in the book, and they correspond with the various channels that I have recorded and put on YouTube. The first book I want to talk about is a textbook called Low Pressure Boilers. It's made by American Technical Publishers, written by Frederick Steingress. And this is kind of the Cadillac of the industry. So if you are looking to be trained on low pressure boiler operation, this would be the textbook to purchase and use if you can find one or borrow one from another fella or lady. This is what I am pretty much following and mirroring, is this particular textbook. In addition to the textbook, I highly recommend that you get Low Pressure Boilers Study Guide. This complements the textbook, and chapter by chapter you will find information in this book that's very beneficial. It'll help you in learning and understanding the safe operation of boilers, all the various components of boilers, how they're built, how they're made, and some of the various distinction between the different types of boilers. Now, the boiler books that I just showed you were 4th edition. They now have a 5th edition. So if you're buying new, purchase the 5th edition Low Pressure Boilers by American Technical Publishers and get the matching Low Pressure Boilers Study Guide that goes with this particular book. This particular book, they have pretty much dropped information on the burning of coal. So in the United States, many of the low pressure boilers that used to burn coal no longer do so. They have been phased out, and it's very rare that you would ever see low pressure boilers burning coal anymore. In addition to that, on the 5th edition, the newest edition, there's additional information on low pressure hot water boilers. There has been a trend in the industry for 50 years, for the heating industry especially, to gravitate away from steam boilers and gravitate to hot water boiler systems for a number of reasons. And there has been in the last 20 years a trend going from conventional hot water boilers to high efficiency hot water boilers, commonly known as condensing boilers. The 5th edition textbook deals with all of those newest trends. So get those books and prepare, read the chapters through, do the study guide, and then listen to the complementary videos. So if you're going through chapter 3 and you've read it, then you would do session 3 on the videos and so forth. In Minnesota, if you are looking for training to understand how to safely operate boilers, low pressure boilers especially, this is the book in Minnesota that I would recommend you get from American Technical Publishers. It's called The Safe Boiler Operation Fundamentals Special Engineer's Guide for the state of Minnesota. You just can't beat it. All kinds of great information in there. I'm not sure what it's like in the various other states, but in Minnesota, the first boiler operator's license that you will get will be what's called the special license. And that special license is special because it's entry level, and it gives you the ability to work in a high pressure boiler plant or a low pressure boiler plant up to certain horsepowers. Typically low pressure up to 50 boiler horsepower, under direct supervision, of course, of experienced operators. So if you're looking to start out in Minnesota, that would be the particular boiler book to read and kind of follow along chapter by chapter and see if you can't match it up to the sessions that I give, and it'll help you immensely. Now, I've done these boiler classes and taught boiler classes across northern Minnesota for many, many years now, and I don't think of myself as a professional trainer. I'm certainly not a professional video person. So I walk through these chapters and I go through these sessions fairly slowly compared to some of the more professional people. But I believe that boiler information and boiler training cannot be absorbed extremely fast. It has to be absorbed over a period of time, and it has to be multifaceted. So by reading the text, you learn a portion of it. By doing the study guide, you learn a portion of it. By listening to my videos, you learn a portion of it. And don't be afraid to jump in and get started on boiler training. Don't get overwhelmed with it. There isn't anybody in the industry, myself included, and anybody else. No one knows everything about boilers. Just nobody does. So don't be intimidated about that. Well, so much for introductions here. I want to talk to you a little story about what happened back in January 1982 down in Spencer, Oklahoma at Star Elementary. It was a nice day. The kids were having fun. It was the noontime, and they were eating in the cafeteria, and things were starting to wind down, and there wasn't a whole lot of kids in the cafeteria, which I guess in hindsight was a blessing. But as there was a few kids left around the cafeteria tables and a few staff in there, an 80-gallon water heater exploded. It had been improperly maintained, and it exploded, and when it did, it killed 5 kids outright and some staff, and a person died the next day. It blew the walls out of the building, it blew the concrete structure apart, it blew the windows out in the parking lot, and it was a devastating time for that community. Are water heaters boilers? Well, yes, they are. They might not be large enough to require daily logs and so forth, but water heaters, by and large, in the industry are a lot of times underlooked. So if you got water heaters in your building, you need to take a look at them and make sure that they're working properly, that the temperature, pressure, safety relief valves are operating correctly, and lift those and test them occasionally so they don't bond themselves chemically tight shut. And if something goes wrong with the burner sequence and things don't shut off, you don't create a small bomb out of a water heater. So when those things erupt, sheetrock walls, concrete block walls, they just don't have a chance. And you can be walking down a hallway or walking through a room, and just behind that wall is a water heater. And if exploded, would put your life in jeopardy. Now this 80-gallon water heater, when it exploded, had just tremendous amount of power. Keep this in mind. One 30-gallon water heater, if it explodes, is equivalent to 2 sticks of dynamite. So if you have water heaters in your building, make sure you maintain them. Flush them. Double check the temperature safety relief valve on them, and then you'll be operating safely, and you will not have incidents or accidents with your water heaters. People seem to go to sleep with those, and they are a lot of times overlooked and neglected. So much for the story about Star Elementary in Spencer, Oklahoma. 1982, what a day that was. And the repercussions and the ripple effects are still being felt today, I'm sure, by people that lived in that area. Like I said, today's video is going to be about fuel systems. Around the country, you will see very commonly fuel systems on boilers that operate off of natural gas. One thing about natural gas, when you purchase natural gas, it's metered out in quantities called therms. And 1 therm is equal to 100,000 BTUs of energy. Natural gas is also lighter than air. So if natural gas escapes out of its piping and so forth, that natural gas will rise inside your room or rise in the atmosphere. Another gas that's commonly used is propane gas, liquid propane. Liquid propane is heavier than air, and it is transported around the country and in trucks with huge bottles or tanks on them, and it is pressurized. They take the propane and they pressurize it down to the point where it turns into a liquid, and they put it into these tanks, and it is a very safe method of storing things. But propane has to, because of all of this pressure and the fact that it is also heavier than air, it will settle and it'll be low in a room or atmosphere. Because of that, it has to have special precautions when it comes to the transportation of it and handling of it. So LP gas is commonly used around the United States. Sometimes it's used as a primary source of fuel, sometimes as a secondary source of fuel. Now, both natural gas and LP gas can be burned in high pressure burner systems or can be burned in low pressure boiler systems. So the difference is where the air and the gases mix in relationship to the boiler and the burner. So very common out there in the industry to have natural gas or propane burners. The other common source of energy for boilers is fuel oil. Fuel oil is very common in some parts of the country where there's no access to natural gas, and maybe the LP gas has a higher cost per BTU, so fuel oil is used as an alternative. The other energy form that is used in boilers today is electricity. And so there's many boilers being energized with electric power throughout the United States. Let's go back to oil. Oil, depending on the temperature, the state of the oil will change. Now, there are several different grades of fuel oil. Generally, for heating situations, the grade starts at a number 2 grade, and it'll work its way up to number 6 grade. The number 2 grade is a lighter weight oil. The number 6 grade is a much heavier oil. The number 2 weight that's lighter has less BTUs per gallon than the number 6 grade. The number 6 grade is also called quite often bunker C. That was an old nickname that was given to it years ago. Now, the viscosity, they talk about the viscosity of oil. It has to do with how easily or what the resistance is against the flow of that oil. If you had a board sitting here and you put lightweight oil up here, it would run down that board very easily. There'd be very little resistance to the running or flow of that oil. But the heavier the grade, the more resistance and the slower the oil will run down a board. When it comes to fuel oil, if you have number 2 fuel oil, generally it is pumped up to the burner under pressure, and it is injected and air is added to it, and it burns quite easily. When you have number 6 oil, it is so heavy and thick that the viscosity is very high. And so to reduce that viscosity on that oil and enable it to be pumped easily and injected into the boiler burners easily, the oil has to be preheated. And when it comes to heavy oil like that, there are a few terms related to fuel oil. One is the pour point. There's a certain temperature, and it depends on the grade of the oil what that temperature would be, where it becomes almost impossible to pour it. And once the temperature gets to a certain temperature, then the oil will pour. The other 2 terms out there is flash point and fire point or ignition point. The flash point is the point where if you have a container of oil and you pass a flame over the top of that container, the fumes will flash but will not continue to burn the oil. That's the flash point. And the fire point is when you have a container of oil and you pass a flame over the top and it ignites and flashes and it continues to burn. That is what is called the fire point, or sometimes called the ignition point. So when you are working with oil, fuel oil, some caution has to be given to the temperature of that oil in relationship to the flash point and the fire point. You don't want to have a storage tank where for whatever reason it gets so hot that it ignites at every little spark, and that becomes very dangerous. But number 6 oil has to be preheated before it gets up to the burner, so it can be pumped and pressurized and atomized into the burner. Now the very common types of fuel oil start out with number 2 fuel oil, then number 4, number 5, and grade 6 or bunker C. The heavier the oil, the more carbon content that's in the oil. And some boiler operations, they need a very consistent recipe or combination of ingredients within their oil. And so they will do what's called ultimate analysis. They will determine and order oil based on exactly what they want in that oil, which will match with all the various high technical burner settings on their burner. So they don't have to be changing the burner settings every time they buy oil. Now grade 2 has about 141,000 BTUs per gallon. and grade 6 has about 150,000 BTUs per gallon. So the heavier the oil, the more carbon that's in it, and the more BTU content that is in it. So the trade-off is the heavier it gets, you have to preheat the oil before it gets up to the burner. Now, in dealing with fuel oil, as it's being discharged or pumped from the tank up to the burner, it has to go through strainers just in case there's particulate matter in that oil that might plug up the burner or the solenoid valve and cause a serious safety concern. So there are strainers or filters in the line. There are some systems out there that burn, they burn round the clock pretty much. In the northern latitudes of the United States, you will find burners or furnaces, they call them, or boilers that will burn continuously for days upon days upon days before they shut off. So the oil as it comes through is strained, and sometimes there will be two strainer systems on the same line. That gives the operator the ability to clean the filters on one strainer or filter system, and the fuel oil can flow through on the other strainer or filter system. So the duplex strainer system is quite common on boilers that need to be continuously run. Like I say, fuel oil is pumped usually with a positive discharge pump up to the burner. There'll be a relief valve there, but it's a set relief valve for a certain set pressure as the oil gets pushed or pressurized into the burner and on into the furnace chamber. At that point, it is mixed with air. It could be air that is compressed air, or it could also be forced in there and atomized or broken up into small particles so it can burn efficiently. It can be atomized by steam. So there's a couple different ways to bring that oil and bring the air into the burner system so it burns very efficiently. And atomizing is the critical thing. It gives you tremendous ability to burn a lot of fuel very efficiently and get the most bang for your buck when you combust that fuel. Now there are also burners out there that are called combination burners. In other words, there's a combination of fuel being brought to the boiler. So you might find in some parts of the country, you will have a boiler that will not only burn natural gas or propane, but it will also burn fuel oil. And the operator would switch between the two types of fuel depending on the availability of the fuel and perhaps the cost of the fuel. So if you're in a part of the country where you burn a lot of fuel oil, and if you were to ever run out of fuel oil or the cost got prohibitive, perhaps you would have a propane tank and then you could burn propane. Or if you were in a part of a country where they had natural gas and there was concern that you could potentially be shut off or cut off from the natural gas for whatever reason, perhaps an accident in a gas line or something, you just wouldn't shut down and have to close the building. You could convert over to maybe LP propane, or you could convert over to fuel oil. So those are combination systems, and there's many boiler plants out there that utilize that technology. One of the things that you will see on boilers in the burner control section is what's called a burner flame safeguard system. This particular one is a digital one. Some of the older boilers that are out there still have the solid state systems, but these here monitor the flame at all times. And this particular flame guard system will walk the boiler burner through its sequence, through its fire sequence. So we'll want to talk a little bit about that. Now, when it comes to a boiler burner sequence, the first thing that happens when a boiler calls for heat and the burner wants to start the burner, will be a segment called Pre-Purge. Now, what does Pre-Purge means? What that means, there's a call for heat, and before any oil or gas can get into the burner, the main force fan for the draft starts up. It's kind of a universally used for the purge system, and it's also used to provide air into the burner for combustion. Anyway, for pre-purge, it will start up and it'll be on high speed. It'll force air through the furnace chamber to make sure that there's no leftover natural gas, LP, or fuel oil fumes. Too much of that in the furnace system could explode when the burner begins to ignite. So we want to have an empty furnace chamber, all of that fuel pushed out of there, pushed out of the boiler and up the stack to the atmosphere. And that's called pre-purge. It's done just strictly for safety. Then the burner goes into what's called ignition trials. The main pilot will be turned on or ignited, or if there's a standing pilot, it'll be there, but the burner safeguard will make sure that pilot flame is established, so that when the main flame or the main gas is turned on, there's something there to ignite it and get that going. So you have pre-purge, and then you have ignition trials. And it's during that ignition trial that the flame scanner system that determines whether or not there's flame in the furnace chamber, those systems are ignored. So there's no way to light a fire if the flame scanner can't see nothing, but during the ignition trials, the flame scanner system does not work. So it allows the valves to open and the sequence of burner operation to continue. It's during the ignition trials that during that time, that's the most unsafe part of operating the burner. So you have post-purge, you have ignition trials. If everything proves to be true, then the main flame opens up, the main valve opens up, and it goes into what's called low fire. Low fire has less fuel going into the burner. It has the ability to warm up the burner and warm up the boiler slowly in that combustion sequence. By warming up the boiler and the furnace slowly, avoids and eliminates the possibility of what's called thermal shock on the boiler. Metal, you do not want it to expand or contract rapidly. It can create metal fatigue and joint fatigue and cause destruction to your boiler. So now you have, in review, you got post-purge, you get rid of all the old stuff. You have ignition trials, now you have main flame, and it's in low fire. In low fire, it'll stay there, depends on what the call for heat is. And it may then go into what's called high fire. So if you need a lot of energy, it'll ramp up. The cam system and the modulator motor will ramp up and open the venturi and open up the solenoid valves, and it'll allow the burner to go into high fire. And then as it burns and becomes satisfied for perhaps the processing that you're doing, or perhaps you don't need to heat anymore in your building, then the burner sequence will bring it back down into low fire before it shuts down. And it does that so that it eliminates or reduces the amount of thermal shock on the boiler. Once you get to low fire, then the burner shuts off. And once the burner shuts off, then the fan goes into what's called post-purge. Post-purge means after the fire is all done. And what it does is it blows again for so many minutes and so many cubic feet of air going through your furnace chamber and boiler and up the stack to rid it of anything that might be left over from the burning process. Keep in mind, the most efficient boiler is the boiler that burns in the lowest rate of fire for the longest periods of time and just barely keeps up with your demand for heat or process. And why is that? Because you have pre-purge and post-purge on every burning cycle. And so if you are burning and you're going into high fire and satisfying everything rapidly and shutting down, you are constantly post-purge and pre-purge, post-purge and pre-purge, and that air is cold air that's getting brought in from the outside. Now in northern Minnesota, northern North Dakota, the northern tier of states, you're bringing air in many times that's 20 below in temperature, and that cools the cools the air that's going into combustion and will cool the combustion itself. Now, when you post-purge and pre-purge, that air is pushed through your burner and it's pushed through the heat exchanger portion of your boiler and is actually cooling down the water that you just put heat in. So if you do that over and over and over and over, you lose efficiency on your boiler. The most efficient boiler is the one that burns continuously at the lowest amount of fire and just barely keeps up with the demand. So keep that in mind. If you have a boiler that's during cold weather that's going on and off and on and off, you might want to have a boiler technician come in and adjust the settings on your burner control so you eliminate that possibility. Just by changing that burner control can save you money and cause the boiler to run much more efficient. Now, I talked a little bit, I mentioned flame scanners. A flame scanner is a small device on a boiler that is always, I guess you could say, it's always looking to see if there's fire there. So if the flame is extinguished inside of a burner for some reason, and the burner continues to push fuel into that furnace chamber, that can be a very, very dangerous thing. It could ignite just on the heat, the residual heat that's inside that boiler, and explode. And so the flame scanners are there to make sure that if the flame goes out, the furnace will shut off. Now you need to test these flame scanners at least a month, every month. So there's different ways to test these flame scanners. You can remove the flame scanner from the boiler itself and cover it with your hand to simulate the flame going out. I would refer to your operation manual on how to do it on your particular boiler, or get a hold of an installer or somebody, if you've never done it, talk to somebody that's had experience, perhaps a repair technician. But the flame has to be running to test it, because when you pull that out and you cover it, you want to see if it's actually shutting off the burner. So do that at least once a month. There's a number of different types of flame scanners. There's Probably one of the most common is the infrared flame scanner. There's a lot of infrared energy, radiant energy that is used in propane fuel oil and LP natural gas, or LP gas. So infrared is a very popular one. There is also the ultraviolet scanner. There are some called the flame rod, and there's some called the photo sensor. They're all used in the industry depending on the types of boilers and the types of flames and so forth that are out there. One will use one will use the other. But in medium-sized boilers, I see a lot of infrared scanners. Read through the fuel system chapter, which I believe is chapter 5 in the book, and it'll show pictures of these scanners and it'll describe them in quite good detail so you understand that. Now, one more time, let's talk about boiler operation. I'm not a professional trainer. I haven't had training on how to do videos, but I know that guys and gals out there sometimes have a difficult time learning and understanding and getting the concept or grasp of boilers. So get the books that I talked about. Read the book, the textbook. Read the corresponding study guide, and then view the corresponding session that I put out on YouTube. So that will be of great advantage to you. Now, the next session coming up will be session 6. So go back to your books and study guides, read that information through and study about it, then bring up session 6 and listen to me as I describe it and give more detail on the information that's in the book. Thank you for listening. Thank you for your interest in safe boiler operation. And be sure you hit the subscribe button. There's no charge involved in that, but it will bring up all the various sessions that I have so that it'll be in the memory of your iPad or your cell phone or your computer, and it'd be easy for you to get from session 1 to session 2 to session 3. You won't be missing out. You won't have to go search the internet or the YouTube channels just to find a particular YouTube. Hit the subscribe button. It'll save you a lot of time. So thank you very much. We'll see you next time.